យើងថ្ងៃនេះយើងចង់បញ្ជាក់បន្ថែមទៀតពាក់ព័ន្ធជាមួយនឹងការសិក្សានៅក្នុងមេរៀនទី1 Introduction to Personal Computer Hardware អញ្ចឹងខ្ញុំចង់សង្ខេបឡើងវិញតិចពាក់ព័ន្ធជាមួយនឹង Computer Hardware ដែលយើងបានស្គាល់គេហៅថា PC Component ហ្នឹងណាយើងអាចសិក្សាពីយើងបានសិក្សាយើងឃើញមានអីគេខ្លះដូចជា case យើងឃើញមានដូចជា power supply ណាយើងមានអីទៀតណា case power supply main board ណាហើយយើងហៅជាយ៉ាងទៀតថាជា motherboard ឃើញមានអីគេទៀតមាន RAM ហើយរួចមានយើងចង់និយាយថាមាន memory មាន room ណាហើយនឹង RAM memory ហ្នឹងមានន័យថាយើងក្នុង memory ហ្នឹងវាមាន room វាមាន RAM ហើយយើងបានសិក្សាអំពី CPU យើងសិក្សាអំពី adapter card យើងសិក្សាពីអីទៀតយើងសិក្សាអំពីគេហៅថា input output device ណា input output device ផ្សេងៗទៀតមុននឹង input output device យើងក៏បានសិក្សាអំពី storage ណា storage device ដែលមានដូចជាគេហៅថា hard disk SSD ហើយនឹង optical យ៉ាងណា optical drive ឬ optical device ហ្នឹងណាបាទយើងសិក្សាបានប៉ុណ្ណឹងហើយយើងបានយកវាទៅតម្លើងជា computer យើងសិក្សាពីឧបករណ៍ទាំងអស់ហ្នឹងអញ្ចឹងថ្ងៃនេះខ្ញុំចង់បង្ហាញថាតើឧបករណ៍ទាំងអស់ហ្នឹងវាធ្វើការយ៉ាងម៉េចដំណើរការយ៉ាងម៉េចអញ្ចឹងបានចំណងជើងវីដេអូថ្ងៃនេះយើងនិយាយអំពីគេហៅថា how multimedia computer work ថាតើដូចជា mainboard ធ្វើការម៉េច memory CPU adapter card ដែលក្នុងនោះក៏មាន component មួយទៀតដែលគេហៅថាដូចជា mouse និង keyboard ណា mouse និង keyboard បានន័យថាជា component នៅខាងក្រៅនោះហើយគេនិយាយថា internal ណាវាមានខាងក្រៅដូចជា mouse និង keyboard បន្ថែមទៀតណា mouse និង keyboard បន្ថែមទៀតដែលជា component នៅខាងក្រៅ system unit ដើម្បីភ្ជាប់ជាមួយនឹង computer ដែរហើយក៏មាន component monitor ទៀតដែរអញ្ចឹងនៅក្នុង system unit គឺមាន case មានអីប៉ុណ្នេះមកហើយក្រៅពីនោះមាន mouse keyboard monitor អញ្ចឹងថ្ងៃនេះខ្ញុំចង់បង្ហាញវីដេអូខ្លះៗហើយអ្នកទាំងនេះអាចទៅធ្វើការ search បន្ថែមទៀតពាក់ព័ន្ធជាមួយថាតើ how multimedia computer work ថាតើប្រភេទ CPU ចេញក្រោយហ្នឹងវាធ្វើការយ៉ាងម៉េចហើយ memory វាធ្វើការយ៉ាងម៉េចហើយ adapter card ហ្នឹងវាធ្វើការយ៉ាងម៉េច hard disk ឬក៏ SSD ធ្វើការយ៉ាងម៉េចអញ្ចឹងវីដេអូរបស់ខ្ញុំនេះបង្ហាញពី monitor ប្រភេទ CRT monitor ហើយ keyboard បង្ហាញអំពីគេហៅថា bus ដែលស្ថិតនៅលើ main board ហើយបង្ហាញពី memory អញ្ចឹងខ្ញុំបង្ហាញលក្ខណៈទូទៅដើម្បីឲ្យអ្នកទាំងអស់នេះបានជាទុនដើម្បីទៅធ្វើការ search បន្ថែមទៀតពីព្រោះថាវីដេអូដែលខ្ញុំបានបង្ហាញនេះវាពាក់ព័ន្ធជាមួយនឹងវីដេអូដែលស្ថិតនៅលើគេហៅថាប្រភេទ component ស៊េរីចាស់បានស៊េរីពីមុនមកប៉ុន្តែដើម្បីឲ្យបានអ្នកទាំងអស់គ្នានឹងអាចបានជាគំនិតបានជាទុនដើម្បីឈានទៅឲ្យមើល component ថ្មីទៀតបាទដោយវីដេអូនេះចឹងគឺពាក់ព័ន្ធជាមួយនឹង monitor ប្រភេទ CRT តើធ្វើការយ៉ាងម៉េចខ្ញុំ highlight ទេដើម្បីឲ្យដូចខ្ញុំបានជំរាបខាងដើមចឹងដើម្បីឲ្យអ្នកទាំងអស់គ្នាហ្នឹងទៅធ្វើការស្រាវជ្រាវបន្ថែមទៀតនៅលើ YouTube ឬក៏នៅលើគេហៅថាwebsite ដែលពាក់ព័ន្ធដែលណែនាំយើងអំពីរបៀបថាតើ computer ឬ component ណាមួយនោះធ្វើការយ៉ាងម៉េចទៅតាម series ទៅតាម model ថ្មី
How does the monitor work? Signals from your computer's video card are loaded into 3 electron guns at the base of the monitor. There is one gun for each of 3 colors: red, blue, and green. These 3 colors, when mixed together, can create all the colors you see on your screen. Now, these guns don't shoot bullets. Instead, they shoot a powerful beam of electrons towards the face of the monitor. The beams pass through the deflection yoke. It uses magnetism to bend the electronic beams so they can sweep across the entire screen and create the picture we see.
What happens once the beams have swept your monitor? Special chemical phosphors are painted on the inside of the monitor. Energy from the electron beams makes the individual phosphors glow either red, blue, or green, depending on the type of phosphor. The stronger the electron beam, the brighter the phosphors glow. A sheet of metal with holes in it helps keep the electron beams aligned exactly with the phosphors. This is called a shadow mask. The beams sweep across the entire screen 60 times per second. It happens so quickly that you are unaware of the firing process. Instead, your screen appears to be a steady, continuous image, just as it does now. Portable notebook computers use a special screen called an LCD, or a liquid.
When you press the K key on your keyboard, a plunger attached to the key pushes against a spring or a rubber dome. The pressure from your finger overpowers the resistance of the spring or dome so that it collapses. This causes two electrical contacts to come together and electricity flows through them, making a circuit. When you lift your finger, the spring or dome pop the key up and the circuit is broken.
How does the computer know which key has been pressed? The current flows from the key to a chip in the keyboard called a microprocessor. This processor matches the keystroke with the table of scan codes. These numbers are used to identify letters in the alphabet. The microprocessor passes this new code number onto a sort of high-tech waiting room in your RAM. That is your random access memory. RAM holds your letter until the PC is ready to use it. At the same time, the keyboard's microprocessor sends a signal to another device, the interrupt controller. It tells your PC to stop what it's doing and pay attention to the waiting keystroke. Next, the interrupt controller sends a signal to the CPU, which passes the task off to the ROM BIOS chip, which yells up to the keyboard controller, "Hey, where's that scan code anyway?" Based on what key has been pressed, the software performs some action, usually displaying a character on the screen.
How do all the different components of your computer communicate with each other? They use a special electronic pathway called a bus. Just like a passenger bus that can transport a large amount of people, the computer's bus can carry a great deal of information. The bus allows the computer's standard peripherals, such as the keyboard and monitor, to talk to each other in other parts of the PC. The bus is made up of numerous electronic pathways called circuit lines, along which power and data travel. The original IBM PC's 8-bit bus has 62 lines, 8 of which transmit power to the adapter cards. Another 8 to 32 lines carry data to various components such as the memory chips or display. The next 20 lines are called address lines. They carry a coded roadmap to where the information is traveling. Each adapter card has a unique destination or address on the route of the bus. The remainder of the bus's lines carry commands for standard computer operations such as reading or writing data. Every component plugged into the bus is constantly looking for signals coming down the command lines. For example, when a signal to write data appears, only the input-output devices recognize the command. Other devices such as the memory circuits do not. Alerted by the write command, the I/O devices check the address lines. If the code matches its address, an adapter accepts the data and follows the new command. Otherwise, the adapter simply ignores the instruction.
There are many types of buses used in PCs today. How fast your PC performs depends on the type of bus it uses. The original IBM PC used an 8-bit bus to transmit data along parallel data lines, like these. The modern 16-bit bus, also called an ISA bus, transports data over 16 lines. To remain compatible, it can also accept older 8-bit adapter cards. The more advanced ISA bus doubles the number of lines again to 32. 8 and 16-bit cards fit into the ESA slots far enough to only contact the first row of 16 connectors. On the other hand, a true ESA board connects with all 32 contacts. The local bus overcomes a major problem with all the previous buses, namely slow speed. The original PC's bus ran at 8 megahertz, but now modern processors can run at 66 megahertz or more. To accommodate these high speeds, the local bus can carry 32 bits of data at a time at the speed of the clock chip. If your local downtown bus suddenly went 10 times faster, you'd definitely sit up and take notice. But for the modern PC bus, it's just another cruise down Main Street.
The brain of the PC is the Central Processing Unit, or CPU. It is a complex microprocessor that consists of hundreds of thousands or even millions of transistors. The CPU is comprised of 6 main components, each performing a separate task. First, a unit called the prefetch queues up the next software instruction for the CPU. When the CPU finishes its current task, the prefetch unit asks for the next instruction. The second and third components are called the paging or segment units. They know the exact memory location of the next instruction and have it retrieved by asking the bus interface unit to send it from RAM. Say to add 2 plus 2. The bus interface unit passes the instruction along to the prefetch unit. The prefetch unit routes it to the decode unit, which translates it into a language the processor can understand. Finally, the instruction is transferred to the execution unit, which carries out the software's commands. The result is then sent back through the paging or segment units, through the bus interface unit, and finally into its correct location in the PC's memory.
We've been looking at an Intel 386 processor, a relative weakling these days. The more powerful Intel 486 processor is similar to the 386, except that it has 2 other components. One is a small 8 kilobyte memory cache. Its purpose is to squirrel away a little data or code so that it can be processed as soon as the CPU is ready. A 486DX processor also has a numeric processor unit built into it to speed things even faster. The newest Intel processor, the Pentium, has 2 memory caches, one for code and one for data. And it has 2 execution units so that 2 separate software instructions can be processed at the same time. These features go a long way to making the Pentium the fastest chip available for the PC.
The hard drive is where your PC stores most of its permanent data. To do that, the data travels from RAM along with software signals that tell the hard drive how to store that data. The hard drive circuits translate those signals into voltage fluctuations. These in turn control the hard drive's moving parts, some of the few moving parts left in the modern computer. Some of the signals control a motor which spins metal-coated platters. Your data is actually stored on these platters. Other signals move the read-write heads to read or write data on the platters. This machinery is so precise that a human hair couldn't even pass between the heads and spinning platters. Yet it all works at terrific speeds.
Let's look at what we just saw in slow motion. When a brief pulse of electricity is sent to the read-write head, it flips on a tiny electromagnet for a fraction of a second. The magnet creates a field, which changes the polarity of a tiny portion of the metal particles which coat each platter's surface. A patterned series of these tiny charged-up areas on the disk represents a single bit of data in the binary number system used by computers. Now, if the current is sent one way through the read-write head, the area is polarized in one direction. If the current is sent in the opposite direction, the polarization is reversed. How do you get data off the hard disk? Just reverse the process. So it's the particles on the disk that get the current in the read-write head moving. Put together millions of these magnetized segments and you've got a file. Now, the pieces of a single file may be scattered all over a drive's platters, kind of like the mess of papers on your desk. So a special extra file keeps track of where everything is. Don't you wish you had something like that?
Multimedia Computer Work ដែលក្នុងនោះវាមាន version ថ្មីៗទៀតដូច ជាពាក់ព័ន្ធមួយ storage ណា SSD ធ្វើការមិន optical drive ប្រភេទ DVD ប្រភេទ Blu-ray ធ្វើការមិនយើងអាចធ្វើការស្រាវជ្រាវបន្ថែមទៀតនៅលើអ៊ីនធឺណិតវីដេអូមិញខ្ញុំគាត់ថាបញ្ជាក់ប្រាប់ថាគ្រប់ component ទាំងអស់ដែលមាននៅលើកុំព្យូទ័រសុទ្ធតែត្រូវបានធ្វើជា simulation ជាវីដេអូដើម្បីឲ្យអ្នកទាំងអស់គ្នាយល់បន្ថែមទៀតទៅលើដំណើរការរបស់វានីមួយៗបាទសូមអរគុណ